Good morning, everybody. I'd like to welcome you to today's webinar from CATIA. It's about the product CAVA, and we will handle the legal compliance in automotive design with CAVA, which is available for CATIA. I hope you can hear me well. And yeah, I'd like to give some information about the webinar from the technical point of view. So I will do the presentation, and yeah, you're currently muted. So if you have any questions during the seminar, please put it in the chat. At the end of the webinar, I will unmute you, and you can also ask your questions verbally. So this session will be recorded. And yeah, so just to make you aware of that. So yeah, just a few words about myself. My name is Wolfgang Klemm. I'm from CATIA in Germany, and I'm the product manager for CAVA. And yeah, CAVA, as you might know, automotive design needs to be compliant with many international standards or regulations. And CAVA is the solution from CATIA, which provides you functionality to efficiently and confidentially validate the compliance of your vehicle design against these regulations or international standards. In this webinar, we will show a few examples here, mainly focus on optimizing your design with respect to crash robustness or also ground clearance requirements. We also will handle how to assess the legal requirements for the vision of the driver. And the third topic would be about finding minimum radius violations in interior and exterior design, in order to fulfill all the legal requirements in this area of minimum radius requirements. So I will only show a few slides and then directly move on to show the product in work. Yeah, maybe just a quick short summary on CAVA. Yes, as I already mentioned, it's CATIA's solution for car design and legal compliance. It will validate your product design with respect to legal standards and other regulations. And this set of regulation will be available in the CAD system for you to apply to your vehicle design and geometry. And we cover standards from all over the world, European standards, US standards, SAE recommendations, and also from Asia and South Pacific standards. Okay, let's talk about the first area, about how to assess your vehicle concept in the early design phase and make it crash robust, and also cover other vehicle packaging questions. Yeah, for this, the CAVA OVA product has some user benefits here. You can use this during the complete design process of your car from concept to homologation. And it helps you to keep the key design parameters and all your analysis features integrated in the design data during the complete development cycle. So as I will show now in a few seconds, I will show some key aspects of the OVA product. So, but now let's switch to CATIA, and with respect to the CAVA concept. So first I wanted to mention our concept on setting up a car project, which can hold all your car parameters like the outline of the vehicle size, positions of wheels and loading planes, but also positions of occupants and seating positions. So yeah, for this we have the CAVA base data function. In the CAVA base data function, you would still see you have the opportunity to add general information about the vehicle, like the vehicle width, the vehicle length, body width, but also front and back overhangs of the vehicle. And the result is already a graphical depiction of how the vehicle size would look. You would also have information about wheel sizes, can enter wheel center points, static and dynamic radii. You can add the seatings for positions for the driver, actually with heel points, steering wheel center, pedal reference point, some information which is important, some different loading planes. Different loadings are required for different aspects of the CAVA analysis, and you can here, for example, activate loading reference planes for different purposes, and you will see there's not just one loading reference plane, but there are several slightly angled planes which are referring to the different loading conditions of a vehicle. Okay, when you have this information, you can already start doing some CAVA work, like start with, for example, with the underfloor analysis, because this is mainly based on your wheel positions and the road plane. So you could, for example, already show the requirements for the slope angle achievement. So if you're having some requirements about the slope angle and you want to achieve certain front angle, CAVA will show you, without having any card geometry, already the boundary surfaces of where you can have clear space to your geometry. And once you add geometry, like if you're having a bumper or front or rear bumper, you can as well do analysis. So in the function, you would select your front elements like this bumper, which you want to check for clearance. And once you add this, CAVA will analyze if the required angle is achieved. And it will also give you some information where the closest point will appear. So you can check your area of clearance for the front angle approach. There are several functions for the underfloor clearance. And yeah, it's about ramp angle, yeah, dynamic curb, and yeah, also the inner angle. So everything you need to know about your underfloor clearance, you can either calculate separately, or you can also combine it in one function, which combines the complete requirements for the underfloor. So you can combine slope angle, dynamic and static curb clearance, also wheel fixing or other ground clearance requirements if you need them. So you are flexibly to add and combine them all. And the result is the combined clearance surface, which you should keep clear with your vehicle design. So you can highlight individual contributors like this slope angle requirement or curb requirement. So you can have an analysis which of the elements is the most critical for your vehicle design. So that's about the underfloor capabilities of CAVA. Another area we have is crash barriers or bumpers. So it's possible to assess some damage or to assess where the contact areas of your impactors will appear on your vehicle. So for example, the check for the low-speed bumper crash tests according to ECR 42, or also the US, comparable US regulations. It's possible to define the pendulum for the impacts. You have several options for the middle pendulum, for the rotated pendulum, and also for the non-centric pendulum impact, the shifted pendulum. And you can define, and each of these pendulum, you can calculate the impacts in 2 different loadings as required by the regulation. And the CAVA output helps you to assess where the where the impactor will touch your car, where the first point of impact would appear, and you can also intrude the impactor into the vehicle by some distance, so you can assess the area which is impacted by the impactor, and you can make some design considerations to minimize the damage of these impactors. Okay, and this is about the bumper check. Many more crash barriers are available for front, side, and rear impact. I will show one additional one, the classical impactor with the ACR impactor, where CAVA as well provides you with the contact points, with the shape of the impactor, and it will also do an assessment of the overlap values to the bumper beam, which have to fulfill, can be calculated with these so-called bumper beam engagement values, which are important for achieving the design goals with respect to the front crash. Okay, one last topic about the OVA module. It also gives you hints about lamp positions, so you can create lamp position checks. The lamp position function will provide you with information about all lamps defined in the respective standards. For example, ECE R48. We have front lamps, side lamps, and rear lamps. You can filter here about the different lamp types. And for each of the lamps, you will get a graphical feedback where the lamp has to be placed. For example, here for the low beam and the front indicator, they need to be in this orange area. And you can do additional tests if you have your light emitting surfaces. You can add light emitting surfaces for your specific lamp types, and you can do additional checks like distance checks. How far, for example, how far is the front indicator lamp away from the low beam lamp? And you can get graphical feedback on these checks where the minimum distance between elements arise. Okay, so these are the points of the OVA product I would like to show. Next on today's agenda would be the area of vision analysis. So we'd like to, for example, this helps you to achieve the legal requirements of the vision for the driver. It supports you with virtual homologation for the rearview mirror, and also helps you to assess ergonomic aspects of vision and also of assisted driving, like the vision field of cameras. Today, I'd like to show you the fields of view, A-pillar obstruction, indirect vision of the driver through the mirror, and also close range vision. Okay, let's get back to our demo model. And with the vision of the driver is regulated in several documents. For the European regulation, it's ECR 125, where there are some definitions of eye positions, but also so-called direct vision of the driver. We have other regulations also for the field of view of the driver, and I'd like to show you, for example, for the fields of view calculation. Fields of views are regulated in ECR 43 and other EU regulations. It will result in outputs of the A and B field on the windshield, which you have to fulfill certain areas. For example, the A field, the small field here, needs to be wiped 100% clear, and the B field would need to be wiped, I think, only 98%. And there are also other requirements in these fields, like the optical properties of the windshield. So it's important to get this information. So when CAVA helps you here to create these fields of view very easily, the only inputs required is the seating reference point in the base data. This will then automatically create the required eye points, in this case, the so-called V points, from which you can determine the angled planes that make up the fields on the windshield. So you can also show these angled planes. Oh, okay, sorry, and I have to, yeah, to be calculated. And you can see how these fields are defined with the help of these pyramids, and you can see the resulting output very easily. This is available for the European standards, but also for the American standards. There's small differences. On one hand, there are three fields, A, B, and C field, but also you will notice CAVA has not created an eye point, but a so-called eye ellipses, because the US standards usually use eye ellipses as the input to derive eye points for a specific purpose, and CAVA will always use the correct eye points or eye ellipses as required by the standards and makes use of them accordingly. Like in this example, the angled planes that make up your vision fields will be tangent to these eye ellipses. Another important requirement for the driver is the A-pillar obstruction. So you need to make sure that your A-pillar is not too wide to block the view of the driver. And in ECE R125, there's a clear definition how you have to measure the A-pillar obstruction. And this is very simplified using CAVA. So in CAVA, it is just a few clicks. So just by defining your view blocking elements of the A-pillar, you can select them. This includes, for example, here all blocking elements of the door frame, but also the non-transparent part of the windshield, the black print, or also some interior trim that might block your view. If you select those, CAVA will automatically calculate the eye positions required, the so-called P points for this element, and it will calculate the required sections where you have to measure the distance. There are two sections, and CAVA will find the inner and outermost points easily and calculate you with the you see here the required angles for the ambinocular view for the driver is 6 degrees. In CAVA, you see the measurement is 2.12 degrees, so that's okay. So this check would pass. And you have some visualization options which helps you to make full use of the available angle. So for example, you see this green line, this would be the limit. So you could add, if you need to, you can add more space to make your A-pillar wider, but not more than to this point, then you would not achieve the current limit. So this is an aspect of direct vision. For the driver, it's also important to have the indirect vision, the required vision through the mirror. So in CAVA, we have the rearview mirror function, which helps you to create a mirror and its analysis simply and easily, reliably. So in CAVA, you can select several types of mirrors. You can use planar glass, spherical glass, or aspherical glass mirrors. If you select a parametric mirror, you can enter its the radius, and in addition, you would just need the rotation point and the contour of the mirror. Then CAVA, just need to have the right contour. Okay, then it's this one. And based on that, CAVA will create the shape of the mirror, but also you will see based on your standard, the required field of view that you have to achieve. In this case, it's a wall standard. It means the measurement is done on a screen behind the car. So you see the required field here in brown. This is what you have to see inside your mirror. So the colored shapes is the outline of the mirror, what you currently see. And CAVA assists you here in positioning your mirror orientation. And so you have a view through the mirror. So you see what the left and the right eye will see on the mirror glass. And so you see this this mirror is large enough to see the complete field, which is required by the regulation. So this is available for all interior mirrors, left, right, and interior. Let's have a look at the passenger side, where this looks like this. In this analysis, we also have included obstructing geometry, so you can add elements that you might also see in the mirror and which might block your view. This could be your fender or the rear bumper. And CAVA will then calculate the obstructed area, and you will see how much blockage you have for each individual eye and for the combined view. The regulation allows an obstruction of up to 10%. So we have a very small obstruction here only. So it's very easy we see that this has fulfilled the vision requirement for this mirror. Okay, let's move on to our third topic, which is the safety radius or the safety requirement. This CAVA safety module enables you to verify all these requirements on safety of pedestrians and occupants. One part of that is the minimum radius analysis on the exterior and the interior. And another part would be the pedestrian protection analysis on the exterior of the car. So I want to show you one of these analysis on the front of a vehicle with the safety radius analysis. So in the safety radius analysis command, you can select the required geometry of, in this case, it's the bumper and the front grille, which needs to be analyzed. And CAVA as an output will provide you with certain output elements. For example, the floor line, which is the magenta line you see on the floor. This is the lower limit for the radius checks. Everything below that, you don't have to verify your minimum radius. And on the other hand, you see some graphical feedback highlighted. So CAVA has analyzed the complete model, and it will check on one hand for the reachability of a point, A point is only deemed reachable if it can be contacted by a sphere of 50 millimeter radius. And points which are not contactable do not need to fulfill the minimum radius requirement. These points you see here with a black feedback. So all other points that are reachable, you will see either in green feedback, and green means, okay, the radius is okay in these areas, but you may also see some red feedback, and these are the critical points you need to find. For example, these points seem to be contactable by the sphere, and to prove that, or if you want to do a detailed analysis, you can go into the so-called interactive mode, and by clicking on an individual point, you can create get the information, details about this point. Here the curvature radius 1.7, which is smaller than the required 2.5 millimeters. You also will see a gap size if the sphere contacts at 2 points. And in this position, this point is reachable and the radius is below the minimum radius. Therefore, it's colored in red, and you would need to think about how to avoid that situation in your design. It considers special regulations for the grill elements. For grill elements, it is defined that the radius might be smaller than 2.5 millimeters, considered that the gap size does not exceed a certain value. In this case, you see it's 1.8 millimeters, but the gap size is small enough so that this value is still okay. So CAVA considers all these special regulations for the safety radius, and you can focus on the critical points easily and try to either change the radius or avoid the contact with the sphere at these positions. So it's possible to create section views of these critical elements. If you need them for documentation, you can easily grab those section shots and put them in any documentation you need. So this is an example for safety radius on the exterior, but it's also available for the interior. And just to highlight two examples, in the interior, the test is a little bit different, or the requirements are different. Oh, sorry, I'm in the wrong model. On the interior, for example, on the dashboard, the requirements depend on the area on the dashboard. So there is an exclusion zone around the steering wheel. Inside this inclusion zone, you don't have to fulfill the requirements because they are covered by the airbag. But there is the so-called head impact zone that you currently see here in the magenta line. There's a specific requirement radius requirement in this zone, and you have the rest of the dashboard where a third radius is required. And in CAVA can calculate all these zones. You see here head impact zone, level of instrument panel line, the excluded area around the steering wheel, and it considers the different radii for these different areas. Head impact zone is 2.5 millimeters. The rest of the interior is 3.2 millimeters, and the roof would be 5 millimeters. In the interactive check here, you would see not only the sphere, how it is reaching an element. If you select an element here, let's have a look at this point, you would see the measured value, but also the pendulum the pendulum which is used to define the head impact zone in the physical test. It is exactly simulated in CAVA with all the movement from the vertical to this point of the dashboard, and it finds the first points of collision, and it gives you, for every interactively selected point, the information about the pendulum length and the angle, how the pendulum would need to be moved to reach this position. So this is available for, on one hand, for the driver, but you can also use it for any other seating position, like the passenger, side passenger in the front. You can also analyze the side door, the impact zone on the door, and find critical points on the door as well, or any other interior geometry. So with that, I'm actually through what I wanted to show. Sorry for a bit of delay due to the technical problems at the beginning, but I hope it was still interesting for you. I also want to point out a few other topics. You have seen currently CAVA in CATIA. So we also offer a similar product. It's called the light car product, with much of functionality is available in CAVA, also based on our light platform, which can work with JT files. So in case you're not a CAVA user, or in your process you have a lot of JT files which you want to analyze, this is a product for you. So if you're interested in that, you may reach out, of course, to us to get more information about this product as well. And yes, there is more information on CAVA on our website. It has been updated recently. There's a lot of good material on it with details for each of the CAVA sub-products, and all listed, all benefits and features, and also videos for each of the sub-products. Last but not least, I'd like to announce here that we soon will have another PLMI forum from Technia Software, which will provide information about the current industry trends and also all Technia products, including CAVA. So we will also have a CAVA Outlook and customer feedback session in that event. So that's coming soon. Registration will start soon. So please visit our website too if you want to get this information and register. Feel free. Okay, then we're actually at the end of my presentation. So I will shortly open now or unmute you. So in case you have any questions, please feel free. So you should be. Yeah, sorry, I seem to have trouble to unmute you. I don't know why I have this problem. So I'm sorry for that as well. But please, if you have any questions on CAVA, reach out to us. You can write to info@technia.com, and please state your interest in CAVA and which area, and we will contact you. And yeah, also in the aftermath of this video, of this webinar, there will be a small survey where you can provide some feedback, and if you'd like to be contacted on certain areas. So please feel free to do so. I thank you for your attention, and yeah, I wish you a good rest of the day. Bye then.